Today we shall start with differentiation. What it says, if y equal to fx is any function, then x is called independent variable and y is called dependent variable. So, whenever there will be change in x, there will be corresponding change in y. What it says, rate of change of y with respect to x, rate of change of y with respect to x is called differentiation of y with respect to x. For example, if I denote distance by x and time by t, then what I can say, distance traveled is function of time. Whenever there will be change in time, there will be change in distance. Rate of change of distance with respect to time shall be denoted by dx upon dt, and in dynamics, what we say, this is velocity. Differentiations are y equal to fx is any function, then differentiation are denoted by either d by dx or differentiation of fx or f dash x or f dash x. So, let us see. There are certain functions of whose differentiation we remember results of certain functions as a formula, though we can prove them. So, first formula for this is differentiation of x raised to n is n x raised to n minus 1, where n is any real number. If I take, say, n equal to 1, differentiation of x will be equal to 1. Differentiation of x raised to minus 1, that will be equal to minus 1 into x raised to minus 2, that will be minus 1 upon x square. Similarly, differentiation of root x will be equal to 1 upon 2 root x. Second formula for this is differentiation of e raised to x is e raised to x. Now, what you have to keep in mind, it is the formula for only e raised to x, nothing else than x. For example, differentiation of e raised to minus x shall not be equal to e raised to minus x. Similarly, differentiation of e raised to sin x shall not be equal to e raised to sin x. Differentiation of e raised to x square shall not be equal to e raised to x square. Those results which I have spoken now, that will be included in composite functions. So, differentiation of e raised to x is e raised to x. Next part is differentiation of a raised to x shall be equal to a raised to x log of a. Whenever base of the log is not mentioned in differential calculus, we do take the base as e. So, differentiation of 5 raised to x will be equal to 5 raised to x log of 5. Now, if differentiation of log x is 1 upon x, what you have to keep in mind, differentiation of log x is 1 upon x, what you have to keep in mind, that base should be e. If base of the logarithm is not e, it should be converted to e. And what we use to convert the base, the formula for logarithm is log of x a to the base b is equal to log of a upon log of b. Log of a upon log of b. So, what you have to remember is differentiation of log x to the base 2 is not equal to 1 upon x. Before differentiating it, we have to convert it in base e. Next result is differentiation of sin x is cos x. What you have to keep in mind, that x should be measured in radians. X should be measured in radians, not in degrees. So, if it is degree, then we apply the formula x degree equal to pi x upon 180. For example, differentiation of sine x degree. That will be equal to differentiation of sine pi x upon 180. Sine pi x upon 180. Next result is differentiation of cos x will be equal to minus sin x. Differentiation of cos x will be minus sin x. Differentiation of tan x will be equal to sec square x. Differentiation of sec x will be equal to sec x tan x. Differentiation of cosec x minus cosec x cot x. Differentiation of cot x equal to minus cosec square x. Similarly, we can remember the formulas for differentiation of inverse functions. Differentiation of sine inverse x will be equal to 1 upon under root of 1 minus x square. Differentiation of cos inverse x will be equal to minus 1 upon under root of 1 minus x square. Differentiation of tan inverse x is equal to 1 upon 1 plus x square. Differentiation of sec inverse x will be 1 upon x under root of 1 minus x square minus 1. Differentiation of cosec inverse x will be equal to minus 1 upon x under root of x square minus 1. Now, next part we do differentiation of the composite functions. Differentiation of the composite functions. We know that if fx and gx are two functions, then f dot g of x equal to f of gx, g dot f of x will be equal to g of fx. All these are called composite functions. So what it says, differentiation of f dot g of x will be equal to differentiation of f of gx. Differentiation of f of gx. Now what you can do while differentiating it, either you find out f dot g and then differentiate it, or what you have to do, differentiation of f dot g of x will be equal to differentiation of f dot g of x will be equal to f of gx, f dash of gx into differentiation of gx. For example, if fx equal to sin x, gx equal to x square, gx equal to x square. So what it says, differentiation of f dot g of x is equal to f dash of gx, matlab cos of x square, into g dash x, that will be 2x. Again see, fx equal to log x, gx equal to sin x, so differentiation of f dot gx will be equal to differentiation of log of f of gx means 1 up sin x into differentiation of sin x will be equal to cos x, that will be equal to cot x. Now, we can convert these results in formulas. Means which one? Differentiation of f dot gx will be equal to f dash of gx into g dash x. We can convert these in the formula. So first formula is differentiation of fx raised to n. So this will be n fx raised to n minus 1 into differentiation of fx. For example, the differentiation of under root of x square plus 1 is there. So differentiation of x square plus 1 will be equal to 1 upon 2 under root of x square plus 1. Then differentiate x square plus 1, that is 2x. So answer will be x upon under root of x square plus 1. Similarly, let us see more example. Differentiation of 1 upon sin x plus cos x is there. So this is 1 upon fx. So minus 1 upon sin x plus cos x ka whole square. And then differentiation of sin x is cos x. Differentiation of cos x is minus sin x. So answer will be 1 upon sin x minus cos x upon sin x plus cos x. Sin x minus cos x upon sin x plus cos x. Next one. Differentiation of 1 upon log of x to the base 10. 1 upon log of x to the base 10. So what you have to keep in mind, first of all, change this into base of e. So this will be equal to log of 10 to the base e upon log x. Now, what will be the differentiation of 1 upon log x? Log of 10 is constant, so we shall keep it out. So differentiation of 1 upon log of x will be equal to minus 1 upon log of x ka whole square minus 1 upon log x ka whole square. Differentiation of log x will be 1 upon x and then log of x log of 10. So answer will be x raised to minus 1 log of x raised to minus 2 minus log of 10. So this will be answer. Next is differentiation of root of sin x. Root of sin x is nothing but sin x raised to half. Apply the formula for fx raised to n. So this will be 1 upon 2 root sin x and differentiation of sin x will be cos x. So answer will be 1 upon 2 root sin x into cos x. Similarly, differentiation of e raised to x was e raised to x. So differentiation of e raised to fx, this is again a composite function. So its differentiation will be e raised to fx into differentiation of fx. For example, if I differentiation of e raised to minus x. So composite function, this will be e raised to minus x and differentiation of minus x will be minus 1. Similarly, if I want differentiation of e raised to tan inverse x, this is again differentiation of e raised to fx. So e raised to tan inverse x, differentiation of tan inverse x will be equal to 1 upon 1 plus x square. Next is differentiation of a raised to fx will be equal to a raised to fx log of a into f dash x, log of a f dash x. So we can do so many questions, 5 raised to 10x, then 5 raised to 10x, 5 raised to 10x log of 5 and differentiation of 10x will be equal to sec square x. Similarly, if you do differentiation of log of sec x plus 10x, this is very important result. This will be 1 upon sec x plus 10x into sec x into sec x plus 10x. sec x plus 10x and sec x plus 10x will cancel. So answer will be sec x. You can take it like this also. Differentiation of log of 10 inverse 10 pi by 4 plus x by 2. So 10 pi by 4 plus x by 2 is equal to sec x plus 10x. So this result is nothing but differentiation of log of sec x plus 10x. Log of sec x plus 10x. We have done this question. So differentiation will be equal to sec x. This is good question because if any student do it by 1 upon 10 pi by 4 plus x by 2, then sec square pi by 4 plus x by 2, then half, then convert it. Otherwise, whoever remembers it, 10 pi by 4 plus x by 2, according to trigonometry, this is nothing but sec x plus 10x. So differentiation will be log of sec x plus 10x. This is a good question. Next is differentiation of log of x plus under root of x square plus 1. If you do it, so 1 upon log of this will be equal to 1 upon x plus under root of x square plus 1. Now, differentiation of x will be 1 plus differentiation of under root of x square will be x upon under root of x square plus 1. If you take LCM and then cancel the quantities in numerator and denominator, answer will be 1 upon under root of x square plus 1. This is the result which we should remember. हमें ये result को we should remember the result whenever the question appears either here or later in any chapter. Differentiation of log of x plus under root of x square plus 1 is 1 upon under root of x square plus 1. Similarly, differentiation of log of sec x plus 10x is sec x. 10 pi by 4 plus x by 2 is equal to sec x plus 10x. Now let us see. Next. In the similar manner, differentiation of sin x is cos x, then differentiation of sin of fx is cos of fx, differentiation of fx. For example, you want to differentiate sin of log x, then it will be equal to cos of log x, and then differentiation of log x will be 1 upon x. Differentiation of cos of fx is minus sin of fx, differentiation of fx, differentiation of tan of fx will be equal to sec square fx into differentiation of fx, sec of fx, similarly cosec of fx. All these results should be treated as a formula. Should be treated as a formula. For example, if it is given y equal to sin of ax plus b, then its differentiation will be equal to cos of ax plus b, differentiation of ax plus b will be equal to a. Next is similarly differentiation of sin inverse x is 1 upon under root of 1 minus x squared. Then differentiation of sin inverse fx will be equal to differentiation of sin inverse fx will be equal to 1 upon under root of 1 minus x ka whole square into differentiation of fx. Differentiation of tan inverse fx 1 upon differentiation of tan inverse fx will be equal to 1 upon fx ka whole square. So this will be equal to 1 upon 1 plus x into differentiation of 1 upon 2 root x. So we have studied differentiation of the composite functions. Differentiation of the composite functions. The first method of doing the composite functions is apply the formula. Differentiation of f dot gx will be equal to f dash gx into g dash x. F dash gx into g dash x, or what you do, you convert them in the formulas. This is very good question. Y equal to sine inverse under root of sine xi. What should be the answer of this? So, what you have to do? Sine inverse under root of sine x 1 upon under root of 1 minus sine x. Then differentiation of root of sine x will be equal to 1 upon 2 under root of sine x into cos x. You convert cos x in under root of 1 minus sine square x. That can be broken into two parts, 1 minus sine x and 1 plus sine x. 1 minus sine x will cancel. So, we shall get here 1 upon 2 under root of 1 plus sine x upon sine x. So, half under root of 1 plus cosec x by 2. This is the answer. This question has been asked in IIT screening. Very good question. Differentiation of sine inverse under root of sine x will be equal to under root of 1 plus cos x into half. Next is, now differentiation of the constant terms. In mathematics, particularly in differential calculus, constants are denoted by either c or by k. So, if a function is constant, there will be no change. So, differentiation of constant function will be equal to 0. Similarly, differentiation of k of fx will be equal to k f dash x. Differentiation of fx into gx, gx into differentiation of f dash x plus fx into differentiation of g dash x. People, some like this, they do use this formula, y equal to uv dy upon dx will be equal to v du by dx plus u dv by dx, u dv upon dx. Similarly, differentiation of fx upon gx is there, then this will be gx differentiation of fx minus fx differentiation of gx upon gx ka whole square. You can remember this formula as y equal to u upon v dy upon dx will be equal to dy upon dx will be equal to v du by dx minus u dv by dx upon v square. You can treat this formula, you can remember this formula in this manner also, but otherwise this seems beautiful. Next is, now what we do, how to differentiate the given function, and for particularly for multiple choice questions. So first of all see if any function which is to be differentiated can be simplified, then first you simplify it and then differentiate it. Now how to simplify? There are 3 or 4 things to simplify the function. First is, if algebraical function, then either by multiplying or dividing, function can be simplified. Second is, if trigonometrical function is there, you can apply the formula of trigonometry to differentiate it. And third is, you apply the rules of logarithm to find the differentiation. For example, if it is given y equal to x square plus x cube plus x square plus x plus 1 upon x. He has given to differentiate it. Now, one student will apply this u upon v and then we shall differentiate it. Otherwise, the simplest is this. You divide it, x cube upon x will be x square. X square upon x will be x. X upon x will be 1 and then 1 upon x. Now, it has been simplified. Differentiation of x square is 2x. Differentiation of x is 1. Differentiation of 1 is 0. And differentiation of 1 upon x is minus 1 upon x square. So, answer will be 2x plus 1 plus 0 minus 1 upon x square. This will be answer. Similarly, let us see this one. He has asked differentiation of cos 2x upon sin x plus cos x. In spite of applying u upon v or fx upon gx, what you do? Cos 2x can be written as cos square x minus sin square x upon sin x plus cos x. Now, factorize it. There will be two factors, cos x minus sin x and cos x plus sin x. One shall be cancelled. Remaining will be differentiation of cos x minus sin x. So, answer will be minus of sin x plus cos x. Similarly, you can see any function which can be first simplified, then differentiating. For example, 2 sin x cos x is to be differentiated. This can be written as sin of 2x. We can take many examples. For example, y equal to under root of 1 plus sin x upon 1 minus sin x. If I multiply numerator and denominator by 1 plus sin x, then this will be equal to 1 plus sin x upon cos x. This will be equal to sec x plus 10x. Differentiation of sec x shall be sec x 10x. Differentiation of 10x will be equal to sec square x. So, this is simplified first and then we have differentiated it. For example, he has given differentiation of 10 pi by 4 plus x by 2. You can write it sec x plus 10x. Sec x plus 10x. Now you can differentiate it. Answer will come immediately. So, what I want to say you, if you can apply any trigonometrical formula and it shall satisfy it shall simplify the function, then first simplify and then find the differentiation. Similarly, if there is a logarithm, we can apply this formula a to log of x to the base a, this will be x. Let us see this question. Differentiation of 5 raised to 3 log of x to the base 5a, 5 raised to 3 log of x to the base 5a. So, this will be 5 raised to 3 log of x to the base 5. This can be written x cube because this multiplication 3 can be raised in for x. So, differentiation of x cube is 3x square. Let's see, देखो क्वेश्चन जो है बहुत डिफिकल्ट लग रहा था, लेकिन आफ्टर सिंप्लीफिकेशन question is converted to this. For example, if he has asked differentiate y equal to log of 1 plus x upon 1 minus x. You apply the formula log of a upon b. This is equal to log of a minus log of b, and then differentiate it. Similarly, y equal to e raised to log of sin x. Once it has been asked this question, so this is y equal to sin x, and differentiation of sin x will be equal to cos x.